welcome to using real-world data to better understand inflammatory bowel disease. My name is Ryan Bach. I'm a senior software engineer at OM1, and I'm joined by Dr. Gary Curran, who's our chief medical officer at OM1. OM1 is a real-world data analytics company that one of the things we produce are research quality data sets around various conditions, and inflammatory bowel disease is one of those. And today we're going to talk briefly about what inflammatory bowel disease is, to give you some background there, and then some of the NLP methods we have to use to get at some of the data we need in support of this data set. And so with that, I want to hand it off to Dr. Curran to go over inflammatory bowel disease.
Thanks, Ryan. If you can go to the next slide. Hello, everybody. I'm Gary Curran. As Ryan said, I'm the Chief Medical Officer at OM1. We're going to be taking a quick ride through the GI tract today, the gastrointestinal tract, to emphasize the importance of the work that Ryan's going to be showing you shortly. But just to give you an idea of the normal GI tract, you may not think about it a whole lot, but it's kind of just a tube inside the body. So in some ways, it's outside the body. And because of that, its important functions, that it allows some things in and not other things. And so the GI tract goes from our mouth all the way through our stomach, but we're going to be focusing on the intestines. That's the lower part there. And there's two main parts of the intestines. There's the small intestine, which is about 20 feet long in most of us. And then the large intestine, it's 5 feet long. Next. So it's not just a tube. There's actually multiple levels to this tube, and it matters because we're going to be talking about two different conditions. One is ulcerative colitis, and the other is Crohn's disease. And ulcerative colitis just affects the inner lining of this tube, whereas Crohn's disease affects all the multiple layers that you see here. Next. So as I mentioned before, that's a tube, but of course we have to let some things into our body. So the GI tract helps us absorb essential nutrients and water. Of course, we need that to live, but it also has the ability and the job to discriminate between food antigens, which we want to let in, and the infectious or toxic agents, which of course we want to keep out. So we need an effective barrier. There's this huge immune system that's going on there. And when it gets knocked out of control, that's sometimes when inflammatory bowel disease develops. Next. So you've heard us say inflammatory bowel disease, IBD. This is not the same as IBS, which is irritable bowel syndrome. Sometimes people get those mixed up, but we're going to be talking about IBD. It's an autoimmune condition, and there's two major disorders that I mentioned. We'll talk about ulcerative colitis. We'll refer to that as UC, and then Crohn's disease, which is CD. And you can see in the cartoons on the right that ulcerative colitis mainly affects the distal part, or that towards the end, the part of the large intestine usually starts in the rectum and then works its way up proximally. And then Crohn's disease, though, can be much more spotty. It usually affects the small intestine and maybe some parts of the large intestine. They have different pathologies and clinical characteristics, but there is substantial overlap. And sometimes when a patient first presents to us, we're not always sure, and we still don't understand what causes these conditions to develop. Next. So I want to talk about mainly ulcerative colitis because that's what the work that Ryan's going to be telling you about. And so it's a chronic inflammatory condition. These patients can have relapsing remitting, so sometimes they feel terrible and sometimes they actually can feel perfectly normal. As I mentioned, it just affects the mucosal, that's the inner lining of that tube. Always involves the rectum, and then as I said, it can extend upwards in a continuous fashion. It doesn't skip. Next. And Crohn's disease, in contrast, I mentioned, can affect transmural, so it can affect the whole wall of the intestine from the inner lining all the way outside, and sometimes even you can have ruptures through that outer wall. But there are skip areas. These patients, unfortunately, because of the additional inflammation, can get narrowing, so we call those strictures or fibrosis. But it almost always involves the ileum, that's the distal part, the end part of the small intestine, and usually the beginning of the large intestine. But again, anywhere of the GI tract can be affected from the mouth down to the anus. Next. So again, focusing on UC, there's a bunch of different clinical manifestations that clinically we want to know about, but also for our work that we do from research and with some of our customers, they want to know about all the different locations and the symptoms and signs that these patients are having. So one thing is colitis. That just means an inflammation of the colon, the large intestine. And one of the things that commonly happens when you have colitis is there's diarrhea, so frequent bowel movements, occasionally with blood, and we'll call that rectal bleeding. So that means when people move their bowels, that actually blood comes out. These patients may have frequent bowel movements. They may have severe abdominal pain that can come and go. And there's also systemic symptoms that they may have as fever, fatigue, weight loss. There's also what we call extraintestinal manifestations. So patients with ulcerative colitis may be more likely to get certain skin conditions or certain types of arthritis. And the severity is really important because that affects how aggressive we are, what types of medications we use. And it may be what we'll call mild disease. Those patients may have 5 or fewer bowel movements per day, with or without blood. But the severe disease, sometimes these patients will have to go to the bathroom, move their bowels 10 times or more per day, and there's almost always blood. So again, rectal bleeding is a key piece that we're trying to understand. Next. So there's all sorts of different classification systems, and I'm not going to go through all of this, but the Montreal classification is one of the most common ones, and that talks about the extent. So that's the E number, letters and numbers you see there, and then severity. And I just want you to focus on the S0, that's the symptoms. 0 is there's no symptoms. You'll see S1 is mild. That is the number of stools, but with or without blood. So again, blood's very important here. And if you go down to the bottom, the severe, the S3, they have 6 or more bloody stools per day. So again, rectal bleeding is really important. Next. And then, as I mentioned, these different symptoms that the patients are having really influence the choice of therapy. And some of the therapies, like the ones on that you'll see on the left, are determined by the anatomic location, severity, or are we trying to induce remission or maintain remission? There's different types that we may have the patients take pills by mouth. Sometimes they take rectal suppositories or enemas. And then you've probably heard about some of the newer drugs. They advertise a lot on TV. We call them biologics. And while they're very effective, they also have more side effects and they're extremely expensive. So again, these signs and symptoms that we extract from the notes here are critical for making our treatment decisions. So now I'll turn it back over to Ryan.
All right, thank you, Dr. Curran. So as Dr. Curran stated earlier, assessing the severity of ulcerative colitis is extremely important. So the example we're going to showcase today is getting at the symptom of rectal bleeding, which is a very important component in the Montreal classification, which is also known as the Mayo score. So there are a few different things we need with these rectal bleeding symptoms. They are rarely documented, if ever, in structured data. They are almost always contained in clinical notes and clinical documentation. So we need natural language processing methods to extract these. And we are going to showcase how we use John Snow Labs to get a portion of these rectal bleeding extractions today. And there's a few things we need. So there's the named entity, the symptom. This is the easiest thing to get because, like traditional NER, named entity recognition, a lot of these terms are ambiguous and have different meanings in different contexts. That's not always usually the case with medical language. When you're talking about clinical documentation and clinical notes, rectal bleeding is almost always going to be a symptom or a problem. So it's not the most difficult area, but it is the first step. The assertion, which is basically a classification of the named entity, if the patient is experiencing it or not, is a very important and a more difficult item to get after because you need the context of the named entity in addition to just a string of text. So there are different assertions we're interested in, primarily if the symptom is present or absent, if the patient is experiencing or not experiencing these symptoms. But there's also conditional and hypothetical. It is common in clinical documentation to have symptoms warned for side effects of medications or just warnings about diseases and things you can experience with a given disease. So while the hypothetical and conditional are important, we're mainly focused on present and absent for this presentation. Those are the most important. We also need dates and relative dates associated with these symptoms, and then we need to establish relationships between them. Here's an example of a note that contains some mentions of rectal bleeding along with a date. This is just a snippet of the note. Some of these clinical notes can be very long, but what we really need to get out of this is we need to get the symptom, the assertion, and we need to get the date. So as we walk through this, we're going to see we need to go to really a labeled data set. So this is the middle sentence in that example, and you can see on the top we have rectal bleeding and the date time labeled, very clean, nice label. We don't need to do anything else with that. And on the bottom we have the assertion. You'll notice the date and time doesn't have an assertion because it doesn't really make sense to assert a date and time. It's not really something the patient is experiencing or not. So we just have the symptom asserted. So I'm going to talk a little bit about the John Solis pipeline we used and the various models. So we did use sentence detection. I assume that these models, and I think this is a safe assumption, that they are designed to work off sentences. Later on, we'll talk about some challenges and some trade-offs to segmenting your notes into sentences. But for now, I wanted to discuss that we did use the healthcare sentence detector. We explored the open source sentence detector, and what we saw was when we spot checked it, we saw various examples of the healthcare sentence detector doing well here, but the open source may be doing better there. So it's honestly a tough thing to evaluate which sentence detector is the best. So based on our data, this data is very technical medical language. We went with the healthcare sentence detector for that reason, because we thought, well, we've got a lot of medical language in here, so we assume even though we may not be able to definitively identify the best sentence detector, we're going to go with the healthcare one. And that's a similar situation for the embeddings. We didn't try the open source embeddings because due to the amount of technical medical language in these notes, we assumed that the clinical embeddings were going to do the best. And then for named entity recognition, we explored 5 different models and then ended up going with one of the JSL models. As you can see, the slim version there, if you're familiar with these models at all. And then the clinical model as well. We don't have any memory issues, so we use the largest models possible because we know they're going to have the most parameters and the largest training data behind them. And as far as assertion goes, we paired the JSL model with a JSL assertion model, and we paired the clinical model with the detect assertion status model. It's a little challenging to determine which model should go with which NER, which assertion model should go with which NER model. So I'll talk a little bit about that later. But these worked out pretty well for us. So next, we're going to dive into some specific examples of what this pipeline looks like in practice. So you can see here at the top, this is the paragraph that we had highlighted earlier from that note, and we really want this segmented into 3 sentences. This is a very clean example. You have a lot of grammatically correct text here with not a lot of misspellings or mistypes. So it segments quite nicely. What you see here is you have the 3 sentences below, and these are all evaluated independently through the John Solis pipeline. And you see that middle sentence there is really key because it's got the date and the symptom for us. And then looking at the NER, we want to go from these sentences to labeled data. So this is what the named entity recognition, this is the JSL model. There are definitely more entities available for these models. But since we're only interested in the symptoms and the dates, that's all I have listed here. That middle sentence there has got the date and time. The last sentence has an additional symptom. That's not really a big deal. We can just ignore that, but we have a nice clean label here for each rectal bleeding mention, and then a nice clean label for the date. And then lastly, we want to go from labeled data to assertions. So we want to classify each of these symptom entities as present, absent. Of course, there are other ones in this model, such as hypothetical, conditional, but we're mainly interested in present. These examples all happen to be present, so we get a nice accurate label there for each mention. But I do want to mention that we are interested in the absent as well, because it is pretty common for negations to be in these notes, what we call a negation. The patient is not experiencing this symptom. And so we have a couple examples here. Just want to call it that we are interested in those, even though our examples just had present. And lastly, we want to go from labeled data to establishing relationships between the symptoms and the dates. You can see here we need both the hard-coded dates, like you see in the first example. We also need the relative dates, like in the second example, and we need to establish a relationship between them. We're not going to go into detail here. We are aware that John Snow Labs has capabilities for relation extraction, and we've explored it a little bit, but we have some pretty good proprietary models that we use to establish these relationships. So the relation extraction is not part of the JS Labs pipeline for this particular project, but it is something that we needed to do. So I wanted to mention it. So now I'm going to talk about some of the challenges we experienced using John Snow Labs on some of this real world data. I'm going to start with sentence detection. This is a different note than was shown earlier. And as you can see, if we look at the first sentence, we see patient also reportedly had nausea in, that's de-identified data, but is a mental institute location in the past. So after that in the past phrase, I should see a period, but I don't. I see the next sentence, which says, no history of recent alcohol substance use was noted reported. Now I should see a period here, but I don't. I see the next sentence, positive family psychiatric history was documented. Now I should see a period there, but I don't. So this is fairly common in real world data where you'll have, data that is not grammatically correct, mistypes, misspellings. What we end up with is what we call what is an underparsed sentence. So this sentence likely spans the whole note. And even if you have a few of these in your data, not necessarily, it doesn't take a lot. It can really slow down your pipeline, the performance of it, because it's trying to process a very large block of text. Now, this isn't necessarily a problem with the model. It's just a consequence of having messy data. I think, it would take a person, it would be very difficult for a person to probably parse this up into sentences, let alone, having training a model to do it, given the fact that we don't have those periods or any kind of delimiter between sentences besides spaces. There's also, I don't have an example of it, but there's also cases where we get what we call over-parsing, where if you have a sentence that contains your symptom mentioned, such as rectal bleeding, and then you have the assertion context as well, and that can and does get split. So what you end up with was a sentence A having your symptom, sentence B having your assertion context, and then you get the wrong assertion because these sentences are evaluated independently of each other. And this is a bit of a trade-off with working with segmenting your text into sentences. It makes the data a lot easier to work with because there's a lot shorter spans of text. But you do potentially separate context, and these sentences are evaluated independently of each other. So we did experience that as well. These are not huge challenges to overcome, but they are something we did experience. So we did skip clinical embeddings. So I'll just mention right now that we didn't evaluate clinical embeddings on its own. We actually overall evaluated this entire pipeline because that's just a lot more efficient way to do things. So we would maybe spot check a few things in each component besides clinical embeddings, because embeddings can be a little tough to evaluate. I am a little curious on embeddings to see if there was a lot of out of vocabulary terms, and just to kind of see what's going to happen, but it's going to be hard to overall evaluate how well they're performing. So what we do is we evaluate everything after the pipeline is finished, and that becomes our validation. It's just a more efficient way to do things. So I don't have anything on clinical embeddings because we included that in our overall pipeline evaluation. But for named entity recognition, one of the challenges we saw that these named entities can and are commonly noisy, messy, and inconsistent. So what you see here is this symptom. Before, we had very clean labels of rectal bleeding. Makes the data very easy to work with when it's on the output. But we see a lot of variation in the named entities. So these extra words inside this named entity, there's occasional small amounts of rectal bleeding is a symptom. The most important thing here is that rectal bleeding is captured, and it is. But this does make the data more difficult to work with on the output. And sometimes these extra words, would be considered part of the symptom. So it's not always, I would say an issue where you're getting a better symptom output. But they can be noisy. It does make this stuff a little bit more difficult to work with. And another example of this is we see multiple symptoms inside a single named entity. Now, again, this is like maybe a consequence more of the data rather than the model, because if you had commas here, it's likely these would be separate symptoms. But since there's no commas, not really a grammatically correct sentence, then what we see here is all of the symptoms get included in this single entity. Again, most importantly, rectal bleeding is included, but again, it makes this data a little bit harder to work with on the output. So looking at assertion, some of the challenges we had with assertion is the assertion models generally do not do well on long lists of symptoms. So you see this example is a sentence of what we call a review of system. The GI is a header that stands for gastrointestinal. And then the assertion here is at the beginning, although we do see lots of review of systems where this assertion can be embedded within each symptom, or it can change mid list on us. But anyway, this example just shows the single assertion at the beginning. So all of these symptoms should be absent. And you see it does pretty good on the first few, but then at the end, we see that it starts to get confused. We see rectal bleeding as hypothetical when that should be absent, and we see unintentional weight loss as hypothetical. And this is not the longest review of system we see. We see a lot longer ones in practice, but they really struggle here. So it was important for us to be able to identify these and filter them out of our results, because we know that we cannot rely on these. And here's another example. This is another review of systems we see. It's a shorter list, but it has this symbolic language where the assertion is a positive or a minus sign, implying, the patient is or isn't experiencing something. And you can see it doesn't do well here at all, and this is fairly common. I'm sure the data scientists at Johnson Labs would not be surprised at this, because there likely isn't any training data like this for the models. And we discuss augmenting these models with our own data, but as you know, that would require labeling a set of data, which requires clinical expertise, and then you need to have multiple labelers, then you have to deal with agreements. So it's not the easiest task to do, although it is something we have considered. Luckily, we didn't have to do that with this. We were just able to filter and find the stuff that works well for us. But nevertheless, it does struggle with this type of data, which is fairly common in our data. So I do want to mention one other thing of difficulty finding the best assertion model for a given named entity recognition model. So the named entity recognition models are not too difficult to identify. You can go off the entities and the descriptions, and usually you can get to a reasonable set of models, in which case we had 4 or 5. I'm just going to say 5 for example's sake. But then I go to the assertion and I'm like, okay, which assertion model do I use? And I approached Johnson Labs and I said, hey, I want to know the best assertion model to use with this NER model. And they replied to me that you can use any assertion model with any NER model. And I'm like, okay, well, if I identify, so there's 33 assertion models here. Let's say I can narrow that down to, let's say 5, based on the model description and the assertions that it's making. So I have 5 assertion models and 5 NER models. That's 25 model combinations to manually evaluate, which is not really a practical thing. So what I ended up doing was I went to the assertion model on their documentation on their models page, and there's this how to use example on each of their models, and I basically worked my way backwards. So I would start with the assertion model and I say, okay, what are they using for their example, for their NER model? And that's the one I would go with. Now, in this case, this is the JSL model, the NER JSL. There are different versions of that JSL model, and I assume that each version would work with this assertion model. But that's the best way I found to determine the best assertion model. And it did work pretty well, at least help me narrow things down and be able to, find a set of models that I could manually evaluate practically. Okay, so just to wrap up, Johnson Labs technology gave us a sizable increase in rectal bleeding extractions. Now, when I say sizable increase, I want to emphasize that Johnson Labs technology was a supplement to some existing proprietary models that we use to extract. If we were to rely, I didn't talk about precision specifically, but if we were to rely on Johnson Labs exclusively on our data, the precision would not be high enough. The precision was good, but not great. But when we combine the data with our high precision proprietary models, we have very high precision proprietary models, then we have, we exceed our threshold of overall precision. So it is a great supplement to our existing capabilities, but it's not something we could rely on independently without, going down some kind of data augmentation route, which of course, would require our resources to label a data set. So these extractions were used in calculating that Mayo score. This is talking about the partial Mayo score. There's different versions of the Mayo score, but that's not important. The important part is that it's an important component of UC disease severity assessments. Now, that is the use case we highlighted here, but these symptom strategies can be used for additional analysis to support other research efforts. Some of our primary customers are pharmaceutical customers or researchers that are looking on what diseases they can treat, how they can treat them, what kind of symptoms are patients experiencing, are they taking various medications, what do those results look like? So they're not limited to the Mayo score. They can be used in other research efforts. And with that, we'll wrap up. Thanks, everybody.